For the introduction of data science, the first thing I want to talk about is data schema. So why is it so important to understand data schema? People tend to ask me, don't you do big data, machine learning, data modeling? All those terms are correct, but without understanding your data, you cannot build any models. You need to understand how the data are connected together and then need to be able to pull the metrics out of your database and make sense of it. So most of the data is stored in a table format like columns and rows. Most of people are most familiar with Excel formatted data, which you can just see the entire data set. But in a database, you're mostly just gonna see tables and columns. So imagine you have a customer table. You're gonna have data like customer ID, name, and email. The customer ID will be the most unique identifier for this table. So imagine if you're running Amazon as a platform. You might have tables like customers. So each time a customer signs up, that customer will be added as an additional row of data for the customers table. And then you might also have orders where each time a customer makes an order, it will be added into an orders table. And then you might also have products, which give you a specific information about products. And it might tell you things like descriptions and even star ratings on Amazon. And then you might also have shipper, who are the people who actually ship to Amazon products to our customers. And then you have suppliers, who are the people who posted the product on Amazon to be sold on the Amazon platform. And then you might also have employees table that actually took care of a customer support ticket. So primary key. Imagine if you look at the customer table and the columns available are customer ID, name, address, city, postal code, and country. So how do you know which one is a primary key? Primary key, obviously a key means it's unique to the row, and a primary just means that it's the most unique identifier for this table. And if you go back and look at the data, which one would that be? Obviously, it will be the customer ID because that's the most unique identifier you can find in the customers table. So most of the database companies you work with are relational database. And if you have a customers table, you might want to look at, what other tables have customer information and how do you make connections between the two tables. So you might have orders table that has order ID, customer ID, employee ID, and a date, so on. The customer ID is our primary key for customers table. And then there's also a customer ID in the orders table, which is called a foreign key. And you make the relationship between the two tables. That's how you'll be able to, collect more information from both tables. So you'll actually know who that customer is that actually made that order. And to keep in mind that foreign key is usually more duplicated because that's not the primary key that's unique per row. And so the orders table, order ID would be the primary key for orders table. So now I want to talk about 4 different types of table relationships. The most commonly used is probably many to one, but we're going to go over all of them. So you have many to one to many, one to one, and many to many. So for many to one, it will be, imagine if you're joining the orders table with the customers table. And because in the orders table, there are multiple customer ID, which is why it's many, and to one because customers table only has one unique customer ID per row. And you usually would do that because you want to see who that customer is that made that specific order. And then you can get like maybe a count of orders for that day for that customer. And you also have one to many. So one to many would happen if you have customers table join with the orders table. And why would you want to do that? Mainly because you might have customers that did not make an order that day or for that month or whatever, but you still want to be make sure that you capture all the customers even though the order counts might be zero, and you do want to show that to your business stakeholders. You also have one-to-one. It seems like it's like very silly. Like, why would you have something that's one-to-one? Like, aren't you just duplicating information? In the real world, I would say that you mostly will use one-to-one relationship because you have aggregated table from two different tables, and they're both aggregated on a daily basis. So then you have a date key as your primary key, and it's only both aggregated table only has one day per row. So then it's a one-to-one relationship, and then you have many-to-many. So that will only be many-to-many if you join a two orders table together, but by customer ID. So you have multiple customer ID and join with multiple customer ID. And why would you want to do that? So, most commonly used case is probably like if you want to say a customer who made an order today, what's the total number of orders they made in the last 7 days? And in this case, you want to join all the possible orders together for that customer, but then at the end you might want to filter out to only last 7 days, so you are able to make connections between your tables, like the customers table, the orders table, and you also might have order details table. And you try to find some ID or some key can map between all three tables. And then you find, okay, so there's customer's ID in the orders table that's also in the customer's table. And then you also have order ID that exists both in the orders table and the order details table. Usually the primary key is the table name and then add an ID at the end, which tells you that's the most unique identifier of that table. And then you also have customer ID in the orders table that maps you back to the customers table, which is called a foreign key, and that's in a blue circle. So thinking about the relationship between tables. So if you're looking from customers table to the orders table, you're essentially joining from one to many because you have one customer ID, but you can map it to many customer ID in the orders table. And same thing for the orders ID in the orders table, which is unique and mapped to the order details table, which each order can have multiple products and multiple quantity. So what are the three types of tables that companies tend to use? And these are terminologies that big companies use. There's the fact table, which is the most granular data you can get. It pretty much documents every single detail about like each log. It can be like the orders table in the more raw format. It has like every single ID for orders, and then also every single product. And then you have dim tables. It's usually the lookup table you want, and customers table would be the best example for dim table. It's pretty much just lookup for the dimensions. And then you also have the ag tables, which is aggregated data. Let's say the orders table, but on a daily aggregated on a daily basis by the customer by product. But it takes a summation of all the orders that's made by that day. So ideally, you don't want to use the fact table unless you have to, because it's like very granular, so it's like it takes a long time to run versus the aggregated table. So most of the time you'll be using aggregated table maybe with a dim table, but that's really all you need. So let's look at the two tables that we looked at earlier, like the customers table and orders table. Now we also have a monthly orders table. So let's try to identify what kind of table these tables are. So like what I said earlier, the customers table would be the dim table. because it tells you specific dimensions about the customers and give you specific details about customers. And an orders table will be a fact table because it actually gives you the most granular order about every single time the order has happened. And then you also have the monthly orders table, which will be the aggregated table because it actually takes summation of each month's order, segregated by the customer ID and the product ID. And then you can see here the customer ID is available in the monthly orders table, and that can actually be mapped all the way back to the customers table. And to keep in mind, usually the fact table or ag table would have a date key. And why is this so important? Because most of the time companies try to store data, especially a company has a lot of data, will try to store data in Hive, which is a filing system that's partitioned by date. Just to give an easier example, in the monthly orders table, each data will be stored in a file based on like May, June, and July. And it's very important to understand this because you always want to see what the data looks like. But when you're pulling the data, make sure that you don't pull like the entire database. That way, the server might just crash and just not be able to respond to your request because it has like so much data. And so it's very important to keep in mind every time you want to pull data from Hive, you should always try to filter based on the date key. So if you try to use SQL to look at, fact data, and then, it's very commonly used, people do select star from orders. So star here just means that you're pulling every single available column from the orders table. But you should always remember to add a filter for date key. I'm gonna have sample data link for the SQL practice and down below, but you should always try to filter out based on date key as much as possible. And sometimes it might not be called a date key, but you should always look for the date column for that table. And then the where clause is where you can filter the data. Same thing for aggregated data. You have monthly orders that tells you, which month has like most orders or something. But you should always add a date key filter to make sure that you don't pull maybe like 10 years of data if the company has 10 years of data, right? And if your point is just to see how the data looks like, then there's really no point of pulling so much data if you just want to see the actual rows. And then lastly, for the dim data, so dim data usually does not have date key because it's just a dimension table, and usually it's not that big, and it usually gets updated if let's say the customer update their information about their name, then that data will be updated. It will not store the historical data, so you don't have problem of you have to use the date key or anything. So you can simply just do select star from customers, and that will get you the actual customers data. And okay, so that's what I have covered. Just to summarize what we have covered in this. So we talked about a primary key, which is the primary identifier for the table, like the customer ID in the customers table. And then you have what's called foreign key, which is a key that maps you to the other table, but it's not the most unique identifier for that table, like the customer ID in the orders table. And then we also cover the 3 types of tables, like the dim table, aggregated table, fact table, which is the most raw logs of the data. And then we also talked the 4 types of table relationships, like many to one, one to many, one to one, many to many, and different use cases of them. And lastly, most important, like when you start off looking at the data, you always want to see how the data actually looks like to get you an idea and kind of imagine what the data is like in your head. but you should always filter down to maybe 1 day, if it's a daily table or fact table, and then maybe like 1 month if it's a monthly table, for aggregated table. And because Hive is very slow, but it's the cheapest option to store the data, so you should, and because it's like, partitioned by the dates, you should definitely always use a where clause for your date filter.